Hello everyone, this is Hajing Tian. In this video, we are learning 4.2 transitions and of graph of sine and cosine function. In college algebra, we have learned the transformations. So based on the f of x, we do some transformations like stretching, shrinking, horizontal shifting, or vertical shifting. And now let's do the same thing on the sine and cosine. So if I have a function, for example, we say this is f of x. And if I'm doing some horizontal shifting, so inside of the parentheses, I will do something on the x. If I have f of x plus 2, so x is abnormal. This is x, this is y, positive, negative x axis, positive x-axis. If I have x plus 2, I'm moving the negative position or move to the left. That means all my x value minus 2. Even we have a addition or we add 2, but to the actual value we subtract by 2. If we have f of x minus 3, so I'm moving to the right 3 units, all the x value plus 3. So sine and cosine, they have the same thing. Let me erase this. So for the sine, in the parentheses, we are doing something on the x. So this is horizontal shifting. And if the c is positive, we're moving to the left. If c is negative, we're moving to the right. For the cosine, we have the same horizontal shifting. So x plus c. Let's see the first image. Graph y equals sine. In the parentheses, x minus pi over 3 over 1 period. So what's the meaning of x minus pi over 3? So this must be horizontal shifting because I'm changing the x value. I'm moving to the right or left? We're moving to the right because it is minus. So minus, we're moving to the positive direction. So moving to the right, pi over 3 units. Okay, so first I'm going to draw a graph of sine function. So what are the 5 key points for the sine function? So there are 0, 0, and here is pi over 2 or half pi, 1, pi 0. Next point is 3 pi over 2, negative 1. Next point is 2 pi, 0. So I need to move all of these points to the right, pi over 3 unit. So first point from x equals 0, get pi over 3. And every point, key point, move to the right, pi over 3 unit. So this point move to here, this point move to here. So move all the x value, pi over 3 unit, or add pi over 3 unit. Okay, let's see next example. Graph the y equals 3, cosine plus pi over 4. So this is not just the horizontal shifting. It also has the vertical stretching. Okay, so which one goes first? In the college algebra, we have learned that horizontal shifting goes first and then stretching. But we also concluded that we can start from inside to outside if I have for example, x minus 4 plus 7, for example. So I will start from inside of the parentheses. We do the horizontal shifting first. We're moving to the right for unit. That means all the x plus 4. And second, we'll do the 2 because most inside of the parentheses, and then I'm moving outside, I meet that 2. So that means I'm stretching vertically all the y's value multiplied by 2. So that's stretching all the y times 2. And number 3, we have a negative sign. That's a reflection along the x-axis, all the y times negative 1. And number 4, we have vertically shifting. So we have plus 7. We're moving up 7 units, all the y's value plus 7. So this is a review of the college algebra. And for the sine and cosine function, we do have the same transformations. We're starting from inside of the parentheses, then move outside. So the first transformation in the parentheses is moving to the left pi over 4 unit, all the x minus pi over 4. Second transformation is the 3. So second transformation is stretching vertically. So all the y's value multiplied by 3. All right, we can follow the 2 steps to graph my function. First, I need to have a function of cosine. And based on that function, I will do the transformation. So let's use the dashed curve to graph the cosine. What is the cosine graph? So from 0 to 2 pi is 1 full cycle. And the first point is the peak. And then last point is the peak. So in the middle, we have half pi 0, pi -1, and then 3 power 2, 0. Next one is the peak. So I can use dash curve, graph it. Okay, based on this one, let's do the first transformation. Move every point to the left, pi over 4 units. So the first point must be negative pi over 4 because I'm moving to the left. So let's use this point, move to the left, pi over 4 units. And next key point, move to the left, pi over 4 unit. Next key point is here. Next key point, move to the left. Next key point, move to the left, pi over 4 units. Then I'm using the dash curve, connect them. So the transformation will not change the shape of the graph. So I'm still having a graph of cosine. And next transformation is stretch 3 times of all the y's value. Okay, so I only stretch the key points y's value. So x keep the same. So first, the first key point, y equals 1. So because this is 1. So 1 times 3 is 3. My first key point is here. And second key point, from 0 multiplied by 3 is 0. And next key point, -1 and multiplied by 3 is -3. Next key point, 0 times 3 is 0. So make a big red point. And next key point is 1 multiplied by 3 is +3. So let's use the solid curve, connect all of these. So I'm trying my best to graph it perfectly. Okay. On your homework, you are not graphing it by your hand. You just use a computer. It will help you graph it perfectly. No, I don't have this kind of software, so I graph it by my hand. All right, this is a stretched function of the cosine. First, we did the horizontal shifting, and second, we did the vertically stretching. All right, let's see next example. Vertical shifting. So we have learned that if I have f of x plus 2, that means all my y's value plus 2, or move up 2 units. -2 means move down 2 units. And for the sine, cosine, they have the same thing. So after the sine, I plus d, and after cosine, I plus a d. If d is positive, I'm moving up. If d is negative, I'm moving down d unit. Let's see the first one. Graph the y equals sine x plus 1 over 1 period. I'm trying to graph what is the sine function over 1 period. So the sine function, the 1 full cycle is from 0 to 2 pi. And from 0 to 2 pi, I'm having 5 key points, 0, 0. This is half pi, 1, pi 0, 3 pi over 2, -1, and 2 pi 0. So if I'm using a dash curve, connect them. This is my graph of sine function. And based on this one, I'm doing the vertically shifting. I'm going up 1 unit. So every key point, I only look at the key points, then move up 1 unit. X didn't change, only the, oh, I make a mistake, I'm sorry. I didn't see this is 2, I'm thinking this is 1. So let's correct it. I don't want to erase my graph because I think the graph is beautiful. So let's do this. So let's use something to correct this one. We say this is 1, and this is 1, and this is -1. We say this is -2, and I move every point up 1 unit. For example, this point is 2. Okay, so the first point move up 1 unit. I'm getting my point here. Second point move up 1 unit. For example, is a point here. Third point move up 1 unit here. This point, fourth point move up 1 unit. I got here. Next key point move up 1 unit is here. Okay, let's see if we move the every point up 1 unit. Yes, we are. So we use solid curve, connect them. So next time we must be very careful because the XY plane, maybe this is not 1, this is not -1. Maybe they are 2, 4, or 3. So we must read the question very careful. All right, I changed the question. Next one, example 4, graph y equals negative cosine x minus 2 over 1 period. So this time I will look at my graph. This is 2, this is not a 1. So I will put a 1 here. It will remind me that it's not 1. This is -1. And graph the negative cosine x minus 2. Let's figure out what are the transformation of this new function. We were starting from inside to outside. Inside, it is the x. There is no horizontal shifting. And then we move outside. This is the first outside difference. That's negative. So the negative function of the function, that's the reflection along the x-axis. So I can put the first transformation here. That's the reflection along the x-axis. All the y's value becomes negative. And the second transformation is -2. That means going down 2 units. All the y's value -2. All right, we have 2 transformations. I will graph the cosine first and then do these 2 transformations. Okay, let's use this color. So the cosine, we're starting from the peak. Then at the 2 pi, we have another peak. So in the middle, the 5 key points, they are 0, half pi, pi, and 3 pi over 2. And the key point there, the first peak point, and second point is here. Next key point is here. Next key point, last key point. Let's connect them. And then what is the transformation? First one with the reflection along the x-axis. So let's use this one, do the reflection. And then based on the red dashed curve, we do the second transformation, move down 2 unit. So let's see, from -1, move down 2 unit, I'm having -3. And second key point is 0, move down 2 unit, -2. Next key point, -1, move down 2 unit. Sorry. Next key point is here, right? So from this one, move down 2 unit. Is here. And next key point is here, move down 2 unit. Next key point here, move down 2 unit, -3. And then we can connect them with a solid curve. So remember that we will not change the shape of my function. All right, we graphed my cosine function. You can also use the college algebra method to help you find the 5 points, because you remember that in college algebra, we said we can list all the key points of the original function. So let's list them horizontally. So x cosine x, and then do the transformation, have a second table. The x on the top, second y equals negative cosine x minus 2. So do the transformation here. So first list of the 5 key points of the cosine. What are they? The first key point of the cosine is 0, 1. Second key points, pi over 2, 0, pi, negative 1, 3 pi over 2, 0, and 2 pi, positive 1. So based on this, let's do the transformations. We have another 5 key points. And what are the x value? The first one and second transformation. So look at here. I'm thinking it will disappear. No. So the first transformation and second transformation, they did nothing on the x. So I'm having the same x, 0, half pi, pi, 3 pi over 2, 2 pi. And these 2 steps, we did something on the y. So the first value is, use the y, the original y, 1. So 1 times negative 1, then minus 2. What is that? Is negative 1 minus 2 is negative 3. The second, it is, use the second y. So 0 times negative 1 minus 2, negative 2. And third one, use this one multiplied by negative 1, positive 1. Minus 2 is negative 1. And the next one, 0, we have the value negative 2. Next point, 1. 1 times negative 1 minus 2, negative 3. So we have the new 5 key points, 0, negative 3. So find 0, negative 3, the points here. Half pi, negative 2. Third point is pi, negative 1. Third, next point, 3 pi over 2, negative 2. 2 pi, negative 3. Okay. We use the second method to graph my function. You can use either one. But for the typical transformations, I suggest you to use the table here, because it's clearer. You will make less mistake. All right, let's see the number 5 and number 6. Find the trig function. Number 5. Find the trig function of the given graph. We have 2 graphs. How to find the trig function from the graph? So in the previous one, we have learned from the function, I can graph my function. And if from the graph, how to decide the trig function? First, I will see, what does this graph look like? This looks like the cosine function, because my cosine from peak to peak. So if it looks like the cosine function, this is the cosine function. So I will put a cosine here, and I will decide, is there any stretch? Is there horizontal shifting or any stretch horizontally? Okay. Let's see. If there is a stretch vertically, I'm having a in front. But the maximum and minimum, they are 1 and negative 1. So there is no vertically stretching. So A is 1. And how about let's graph the cosine function on this graph. So the cosine from the peak to peak. So point here, point here and point here, and at the 2 pi we have our peak. 2 pi is here, so 2 pi is here. All right, so let's graph it. So let's use the dashed curve. What can you see? Oh, the blue curve is the red curve. Move to the right, pi over 8 unit. The initial point from the 0, 1, the x value from 0 becomes pi over 8. Okay, that means my cosine function will move to the right, pi over 8 units. And then in the parentheses is pi over 8, because only the subtraction means move to the positive direction. So we solved the first equation, the function. We found the first function. So maybe next time we'll graph the original function first, and then find the difference and identify what is the transformation. Let's see the second one. So what does this one look like? It looks like the cosine again. So let's graph the cosine on this picture. So the cosine, the 5 key points. First point, by 3 pi over 2. Second point, and next key points, last key points. Connect them. So what's the difference, or what's the similar part? They are the same shape. The only difference is based on the cosine x. I'm moving up how many units? So here is 1, here is 3. I move up 2 units from 1 to 3. So my function is cosine x and then plus 3, because we are shifting my graph vertically and to the up 3 units. So we add 3 after the cosine function. It's okay you have a parentheses or not, because some students ask me, so do I need to add a parentheses here? It doesn't matter. So if you add the parentheses, you get full credits, and you have no parentheses, you get full credit. All right, let's see next part. Let's do a little bit review. I will not graph them, but I will identify what are the transformations. So first review is there is a in front of the sine or cosine function. That means the vertically stretching or shrinking. So if I have 2 times sine x, I'm stretching vertically. That means all the y's value or sine x function's value times 2. And second one, we have 1/2 in front of the cosine. We're shrinking it vertically. 1/2 times y, or all the y times 1/2. Next one, we'll not only have the vertically stretching, we also have the reflection along the x-axis. So that means all the y's value multiplied by -2. Next transformation, there is a b in front of the x. What is the meaning of that? That's we will do the shrinking or stretching horizontally, because right in front of the x. So x is different from the y. If I have a 2 greater than 1, I'm shrinking it horizontally. So all the x value multiplied by reciprocal of 2, 1/2, becomes 1/2. And how about there is 1/2 in front of the x? We stretch it vertically. So we are having the x, all the x multiplied by reciprocal of 1/2, which is 2 times 2. Next one. So what is this? You will see there's 2, there's a negative sign in front. But in this case, we prefer to have a positive sign in front of the x. We will use even or odd of the function to get rid of the negative sign. Sign is even or odd function. Odd. So the odd function, we have that sign negative x equals negative sine x. I can bring the negative sign outside. We have negative in front. And for this case, if we have a sign negative 2x, if I want to have a positive x in the parentheses, I can bring this negative sign outside. We have negative sine 2x. So we finished the first part, how to identify the transformation from inside then to outside. So first step, inside, we're shrinking my graph. We're shrinking my graph horizontally. So all the x times 1/2. Second transformation is negative sign. That's a reflection along the x-axis. All the y's value becomes its opposite. Okay, let's see. Graph y equals a times sine of bx minus c plus d, and y equals a times cosine of bx minus c plus d. So we call these general form of sine and cosine. So in the previous examples, they are all the very easy transformations. And now we have combined the transformations, all kind of transformations together. And how to graph these complex function. We will learn the properties of the sine and cosine first. Okay, if we have these two kind of complex transformations, first step, we need to make a positive b. If b is negative, let's use even or odd property to get rid of a negative b. For example, if I have the sign negative 2x minus 4 plus 7. So the first part, I will pull out the negative sign. That means I can bring the negative in front. I'm having sine 2x plus 4. You need to bring all the negative from the parentheses. So factor out negative, we have 2x plus 4. So factor out the negative sign, we have 2x plus 4 inside of the parentheses. Then we do the transformation. Another example, if I have 2 cosine negative x minus, so plus 7 again. So get rid of the negative sign, make a positive b. I can use the property of cosine. This is an even function. If we have negative, that means I can ignore that negative sign. We have 2 times cosine x plus 7. Because cosine is even, so I can take it away. All right, let's come back to the other properties of sine and cosine. First one is amplitude. Amplitude is absolute value of a. So it's so that is number in front of the signs. Let's do the absolute value, and the maximum and minimum value of the function all depends on the a, and also the b, the d, the last term d. The period of sine and cosine is 2 pi over b. The phase shift is c over b. So use this c over this b. But sometimes students feel in the parentheses we have a plus c. So it confused me to find the phase shift. Here is the trick. So number 3. How to find the phase shift? You can let all the things in the parentheses equal 0. Solve for the x. bx minus c equals 0. Solve for the x. We plus c both sides. bx equals c. Divided by c both sides. Divided by b. So divided by b both sides. X equals c over b. C over b. And for example, if I have the sign 2x plus 4 pi, for example, and find the phase shift. So phase shift is let all of these equals 0, 2x plus 4x. So 4 pi equals 0, and subtract 4 pi both sides. 2x equals negative 4 pi. And then divide by 2, both sides, x equals negative 2 All right, so we found our x equals -2 pi. So it didn't confuse me because it doesn't matter here is positive or negative. I can solve for my x. And what's the meaning of phase shift? Phase shift is I will move my graph horizontally. So the initial point has changed. Okay, the initial point of the x value has changed. So for example, if I'm having my sine function, I have a phase shift. I say phase shift equals pi over 4 or pi over 2, for example, easier. So I need to move this one to the pi over 2. And second key point, move to the right pi over 2. So I'm having my new graph like this. You'll see before the key point is x equals 0. Now the new initial point x value is half pi because phase shift is half pi. So by finding the phase shift, I can find where my graph will start from. All right, next one is vertical shift, is a d. So after the function, we plus a d, move up d unit. If d is negative, we move down d unit. Move down absolute value of d unit. All right, let's see number 5, one full cycle. One full cycle of the sine function. So for example, sine x. I know that one full cycle is from 0 to 2 pi. Now, inside of the sine function, the input part changed. The input is bx minus c. That means this bx minus c is between one full cycle, 0 to 2 pi. Now we want to find the full cycle of the x. We can solve the x from this inequality. Okay. Next part, find the domain. Domain for all the sine and cosine is from -infinity to infinity, because you will see the graph of the sine and cosine function. They will never stop. So we have all the x could be all the real number. So from -infinity to infinity. The range of the function is, we have a formula. It's a negative absolute value of a plus d less than or equal to y, less than or equal to absolute value of a plus d. So first I need to find what is the a, what is the d, and use this formula, you can find the range. You can also say, I can find my range from the graph. So you can graph my function first, find the maximum value and the minimum value. The range of the function is between the minimum and the maximum value. Okay, let's see the first example. First example, let's identify the identities, and then we start to graph it. So first, let's see the ABC. What is the ABC? So the A is the information in front of the cosine. This is 1. So let's put 1 here. And how about B? B is the value in front of the x, which is 2. What is the C? So let's go back to see our general expression. The general expression here, we all have minus C, minus C. If I have a negative, if we have a positive value, plus pi over 2, the C is negative pi over 2. How about number D? So D, we have nothing after the cosine. If I have add D, so the vertical shifting is D, but there's no D. We put the 0 here. How about the absolute value of A? It is 1, so amplitude is 1. Period is 2 pi over B. So what is the B? B is 2, so 1 period is pi. Phase shift, we talked about this. So if you are using the formula C over B, you can use it. Or you can do this. You can let all the parentheses equal 0. 2x, this is not equal. 2x plus pi over 2 equals 0. Solve for the x. We can minus, put it here, 2x plus half pi equals 0 minus pi, half pi, both sides. 2x equals negative pi over 2. Divided by 2, both sides. X equals negative pi over 4. That means the phase shift is negative pi over 4, or the starting point of the x is negative pi over 4. And next part is graphing my function. So before we start to graph it, I want to find the one full cycle, the new full cycle. The full cycle formula is use everything in the parentheses. 2x plus half pi between 0 and 2 pi. So solve for the x, we can minus half pi, 3 sides. So 2 pi minus half pi is 3 pi over 2. Then divided by 2, all of these three terms. We're having negative pi over 4 less than or equal to x less than or equal to 3 pi over 4. Oh, that means initial point, the x value is negative pi over 4. And the final point, the terminal point for one full cycle or one period is 3 pi over 4. Where is it? It's here. Okay, so how to graph it? We have learned this is a cosine function. And based on the cosine function, what is the transformation? There's no stretching vertically, but we have the horizontally shifting, and there is no vertically shifting. And how to find the five new key points on this function? Let's see. What is the old key points for the cosine? So everybody must know it. So x, cosine x. So for the cosine, the function is from 0 to 2 pi, from peak to peak. I only draw one full cycle. So here, okay, there's one here, here. So we use dash the curve, connect them. This is a cosine. The 5 key points, they are 0, half pi, pi, 3 pi over 2, and 2 pi. The y's value, this is cosine x. The y's value, they are 1, 0, negative 1, 0, 1. And what are the new 5 key points? X, and this is cosine 2x plus pi over 4. So from here, we know one full cycle is bounced between negative pi over 4 and 3 pi over 4. That means my new 5 key points. The first is starting point, x is pi over 4. And last key point is 3 pi over 4. We need to find the middle 3 key points. So how to find the middle 3 key points? Okay, come back to see the cosine function. Okay, so cosine function has 5 key points. This point, this point, this point, this point. Oh, okay. This point and this point. And these 5 key points divides the section from 0 to 2 pi into 4 equal parts. You see, 0 to half pi to pi, pi to 3 pi over 2, and 3 pi over 2 to 2 pi. So the 5 key points make the one full cycle to the 4 equal parts. Oh, what is one full cycle for the cosine? 2 pi. And the 1/4 of the 2 pi is half pi. Right? All right. if I know the initial point and plus 1/4 of 1 full cycle, I can find my second point. Based on my second point, add another 1/4 of the period, get second point. And at the this point, add another 1/4 of the period. And I found all the points here. All right, now let's see, what is the period? We have found it here. The period is pi. And based on the first key point, the first key point is here, and add 1/4 of the pi, I can find my second point. Okay, so I will put some information here. 1/4 times the period is 1/4 times the pi. Oh, 1/4 of the pi is pi over 4. So based on the first point, the x value, I add pi over 4. Second point, as equals 0. Add another 1/4 of the period is pi over 4. Add another pi over 4, I got pi over 2. And add another pi over 4, I got 3 pi over 4. Okay, the last point, I don't need to do the addition because I can find it from here. All right, how about the y's value? We figure out the transformation of the x. We found all the x value. How about y's value? Okay, let's see the function. Do we have any transformation on the y part? Let's see. No, we do not, because everything we worked based on the x. If I have the y's value changing, I can have a here. That's a stretching vertically or shrinking vertically. Or we can do this. We can have a d that's vertically shifting. Or we have negative. We reflect all the y's value along the x-axis. So we have no changing on the y part. They have the same y's value with the cosine. So this is 1, 0, -1, 0, 1. I just copy them here. Then we plot the key points. The first key point is negative pi over 4, 1. Second key point, 0, 0. And this is pi over 4. Pi over 4, -1. Half pi, 0. Next key point. 3 pi over 4. This is 3 pi over 4, 1. Okay, so if I connect them, this time I'm using a solid curve. So this is a graph of the cosine of 2x plus pi over 4. Is this an interesting question? Because this is the first example. I explained too much. So let's see next example, number 7. How to graph this one? Let's identify the properties of this function. Let's find the ABCD first. What is the A? In front of the cosine, we have a 2. So you can pause the video and read the question first. So A is 2. B is 4 in front of the x. And C is positive 3 pi, because here satisfy the condition, subtraction or minus. So C is 3 pi. And what is D? D is 3. And what is the amplitude, absolute value of A, which is 2. So what is the period? Period is 2 pi over B. And 2 pi over 4, it is pi over 2. Half pi is the period. What is the phase shift? Phase shift, we can use the formula C over B, but we can also solve the parentheses. 4x minus 3 pi equals 0. Solve for the x. We can do it here. 4x minus 3 pi equals 0. And add 3 pi both sides. 4x equals 3 pi. So divided by 4, both sides, x equals 3 pi over 4. So this is a phase shift. My first x value is 3 pi over 4. So phase shift is 3 pi over 4. That means move to the right 3 pi over 4 unit. Vertical shift is the d after the function. So it is 3. That means I'm moving up 3 units. All right. If I want to graph it, I need to know the one full cycle. What is one full cycle? We can put the parentheses 4x minus 3 pi between the 0 and 2 pi. Find the new full cycle. We can add 3 pi on this inequality, 3 sides. 3 pi less than or equal to 4x less than or equal to 5 pi. And then we can divide it by 4, isolate the x. X is between 3 pi over 4 and less than or equal to 5 pi over 4. So you will see that why my phase shift and my one full cycle, they are the same. They must be the same because the phase shift is the starting point of the x. And the one full cycle is also from the starting point of the x. So if they are different, you may make a mistake. You must make them the same. Ooh. Okay, so what is the next step? So next step, I will list the table of the original function. What is the original function of this? Cosine, cosine again. So this is 0, sorry. This is x. And the bottom is cosine x. So the 5 key points, they are 0, half pi, pi, 3 pi over 2, and 2 pi. And what are the y's value of the cosine? They are positive 1, 0, negative 1, 0, positive 1. So if you don't remember that, graph the cosine function from peak to peak. So the first point is x equals 0, last point is 2 pi. And the first y's value is 1, 0, negative 1, 0, positive 1. And then you can fill out the table. All right, let's see. I need another table to graph my function, the key point of my function. So the function's value is y equals 2 times cosine 4x minus 3 pi plus 3. So maybe I make a bigger first column. So let's see, what is the transformation of the x? Okay, it's too complex. I cannot say it immediately, but I can find all my x value, the transformation based on this one full cycle. Okay, fill out the blank. First point of the x must be 3 pi over 4. And what is the last point? For one full cycle, last point must be 5 pi over 4. In the middle, I need 3 points of the x. For the 3 points, I know that one full cycle can be divided into 4 equal parts. And the distance of each equal parts is 1/4 times the period. What is 1/4 of the period? So the period is, I found it is pi over 2. So we use 1/4. 1/4 times half pi. Oh, sorry. So it's pi over 8. Okay, so from the first initial point, add pi over 8. I'm finding the x value of the second point. So this is 7 pi over 8. How did I find this? So I use 3 pi over 4 plus pi over 8. So increase the top and bottom. I'm getting 6 pi over 8 plus pi over 8. At the tops, I'm having a 7 pi over 8. And do the addition based on the second point, 7 pi over 8 So 7 pi over 8 plus pi over 8 is 8 pi over 8, which is pi. And continue to add a pi over 8. I'm having a 9 pi over 8. And 9 pi over 8 plus pi over 8 is 10 pi over 8. Do the simplification, divided by 2 top and bottom, 5 pi over 4. So that's the last key point. All right, we found all the x value. I didn't use the old method, do the shifting horizontally or shrinking and stretching horizontally. That's too much work. So use this method. I can find all the x new key points of the x value. How about y's value? What are the transformations? So we figure out the x part. And then for the y part, only do the y transformation. I want to get rid of the pink. There's no way to get rid of the pink. So let's keep it. So the y transformation is multiplied by 2, then plus 3. Okay, that means is stretch vertically twice, and then that's y times 2. And the 3 means move up 3 units, all the y plus 3. So let's do these 2 steps for each y's value from the previous table. So here, the first table, the first blank, I should put 2 times y, 2 times 1 plus 3, that is 5. And second point is 2 times 0 plus 3, 3. Next one is 2 times -1 plus 3 is positive 1. And next one is 0, so value is 3. Last one is 2 times 1 plus 3 is 5. All right. We got these 5 key points. Let's plot the key points on my graph. Okay, first key point is 3 pi over 4, 3 pi over 4, 5. So this is 5, this is 3 pi over 4. So first key point is here. Second key point is 7 pi over 8, 3. Do we have 7 pi over 8 on my graph? No, we do not. So let's find it. It is the point between 3 pi over 4 and pi, so in the middle. So this is 7 pi over 8, but the y's value is not 0, it is 3. So find the 3. This is the second key point. And pi 1 is here. And 9 pi over 8. 9 pi over 8 is between pi and 5 pi over 4. Is 9 pi over 8. The y's value is 3. And 5 pi over 4, 5. Okay, let's connect them with a solid curve. So assume this is a beautiful cosine graph. Okay, we finished this one. What is the range of the function? Let me ask you. So from the formula, the range of y is between negative absolute value of a plus d less than or equal to absolute value of a plus d. And now if I can tell from my graph, the highest point is here and lowest point is here. So my y is between 1 and 5. So the range in the interval notation is from 1 to 5. And 1 and 5, they're included. You can also use the formula. So a is 2. So -2 plus d. What is the d? D is 3. And positive 2 plus 3. So this is 1 to 5. So the range is from 1 to 5. Okay, let's erase this. And we'll do the next example, number 8. So if I have a function and how to find all the properties and then how to graph my function. So first, is this the general form? The general form we have learned is the a times, if this is sine bx minus c plus d. Where is the d? There is a 6 in front. So can you move it to the end? Yes. Yes. So let's move the 6 to the end, make a general form. -3 sine, 2x minus pi over 2 plus 6. Oh, move the d to the end. Let's identify the amplitude, period, phase shift, and vertical shift. So first, what is the A? A is -3, B is 2, C is positive pi over 2, and D is 6. What is absolute value? Amplitude. Absolute value of A, 3. What is the period? 2 pi over B, 2 pi over 2. We got pi. And is there any reflection? Yes, we do, because there is a negative sign in front of the sine function. So that's a reflection along the x-axis. So remember that if we have a negative in front of the function, in front of the sine, in front of the cosine, that's a reflection along the x-axis. So make all the y. So before y is here, y is the 1. Now reflected to the bottom, I'm having a -1. All the y becomes is opposite. So multiply by -1. All right. Let's see the reflection along the x-axis. So what is the phase shift? Phase shift, if you don't want to use the formula, set all the parentheses, expression equals 0, solve for the x. So 2x minus pi over 2 equals 0, add pi over 2, both sides, 2x equals pi over 2, divided by 2, both sides, x equals pi over 4. So phase shift is pi over 4. That means my first point is, for the x value is pi over 4. Vertical shift, yes, because the d is 6. We're moving up 6 units. That means all the y's value plus 6. So you can say phase shift is 6. If the phase shift is negative, you can put -6, but here is positive. All right, let's graph it. Before we graph it, can you find one full cycle of the function? Yes, we can. So we will set all the parentheses. 2x minus pi over 2 is greater than or equal to 0, less than or equal to 2 pi. Solve for the x, find the new full cycle. We can add a pi, half pi both sides, 3 sides. 2x less than or equal to 2 pi plus pi over 2 is 5 pi over 2. And then divide by 2. So x is between pi over 4 and 5 pi over 4. So initial point, the x value is pi over 4, must be equal to the phase shift. And the terminal value of the x for one full cycle is 5 pi over 4. All right. How about list the key points? This is a sine function. So let's make it smaller. So I'm finding the sine function key points first. This is x and sine x. And what does the sine look like? The sine function is function graph like this. Initial is 0, terminal is 2 pi. And these 5 key points, they are x equals 0, half pi, pi, 3 pi over 2. Last one is 2 pi. How about y's value? 0, 1, 0, -1, 0. And how about the table of the new function? The x is here, the y is very complex. Y equals 6 minus 3 times sine 2x minus pi over 2. So let's make a bigger first column. Okay, so you can also use the general form because we converted to the general form. Let's use this one because we always use the general form and they are the same. So let's copy the general form. Y equals -3 times sine 2x minus half pi plus 6. So let's see the x value. The initial point x value is pi over 4, and last point is 5 pi over 4, and 3 middle points. So we need to find 1/4 of the period. 1/4 of the period is 1/4 times the period we have found is pi. So it's 1/4 pi. So based on the first x value, we add pi over 4. I'm having half pi. And second, we add 1/4 pi is 3 pi over 4. 3 pi over 4 plus pi over 4, I got pi. Pi plus pi over 4, I have 5 pi over 4. And what are the y's value? We figure out the x part. And the y changing, we have a -3. Let's see. We have a -3, we have a +6. These are the changing in the y. So let's do this. The first value must be based on the original value, y equals 0. I should do this, -3 times the 0 plus 6. So I'm having +6. And second is positive 1, use this one. So -3 times +1 plus 6, because first we do the stretching vertically and reflecting, then +6. So this one is 3. The third point of the y's value is this is 0, so we have the 6. And next one we use -3 times -1 plus 6. This is +9. And the last point, the y equals 0. Oh, sorry. Yes. So y equals 0. So do the computation. I got 6. We have these 5 points. Let's graph it. First point is pi over 4. So this is pi over 4, and this is half pi, and 3 pi over 4 pi. This is 5 pi over 4. Okay, so the first key point is 6. Second key point is 3. Third key point 6. Next key point is 9. Last key point is y's value 6. Okay, we connect them with smooth curve. Okay, I graphed my function. This is a really complex trig function, but we made it. So you can do the conclusion yourself. We did this. And for your homework, it's super easy because my my math lab cannot provide you the graphing function, like graph it by hand and find the 5 key points. So it's super easy. For example, let's solve one question together. So maybe, so how I can do it. Okay, so let's see the last question. Okay, how to graph this one? So let me grab a paper and copy down the function here. I haven't solved this one. So 1/2 times cosine 1/4 x minus pi over 16. So how to graph this one? Let's first see this. Can you find all the property of the cosine function, the A, B, C, D, and also find the phase shift and the vertical shift. And then this is a cosine function. I will click the graph of cosine. So look at my cursor. This is cosine. You see I highlighted, and then I randomly plot it on my graph. So second step. So what is the amplitude? So amplitude is 1/2. What is 1/2? 0.5. So click 0.5. What is the period? So period is 2 pi over b. So 2 pi over 1/4. Okay, flip the 4 to the top. It's 8 pi. So I hope I selected the 8 pi. So this is 8 pi. And what is the vertical shift? There's no vertical shift because the D means vertical shift. So 0 is a D, and vertical shift is is 0. And phase shift, we have learned that set all the parentheses equal to 0. 1/4 x minus pi over 16 equals 0. And solve for the x, I'm having pi over 4, positive pi over 4. We can insert pi over 4. Where is it? I'm sorry. Where is the, oh, here. So we put pi over 4. Okay. Pi, okay. So I click pi, that means pi, and divide it by 4. So no reflection. And then we click save. I'm thinking it didn't give me, yes, it has the phase shift. Save it and check answer. Okay. All right, it's much easier than we are finding the 5 key points. But for my face-to-face class students, so please remember that you must know how to find the 5 key points. And then graph it by these 5 key points, because on your exam, you have no helping tools like the homework. So you must find the 5 key points and connect them with a smooth curve. All right, we're done for today. This is a super long video. I hope you learned everything you want. Okay, see you next video. Have a good one. Bye-bye.